We're going to talk about three different conic sections. We're going to focus on the ellipse, the hyperbola, and the parabola. Circles are also conic sections, but we're not going to talk about them here. So here we have an ellipse. We're going to first talk about when they're centered at the origin. So the center is 0, 0. Now when we're talking about the center, we're talking about like right there, kind of in the middle of the ellipse. So you've heard of elliptical machines. That's the shape that it's making. Our planets orbit in an elliptical shape. Their orbits are. Anyway, examples of ellipses that you've maybe familiar with. Okay, so with that, I'm going to talk about the major axis, and I'm going to try to put these in different colors, and hopefully this will help. So the major axis is the one that goes the long part of the ellipse, and it goes right through the center. So that's going to be the major axis right there in green, okay? The minor axis, I'll put that in red, is the short, the short distance going through the center, and that would be the minor axis then. I'm trying not to put a lot of writing on the actual ellipse so that you'll be able to see that. Now, I have two pictures here. The first one I'm doing, I'm going to call it like a pancake shape. It's elongated along the x-axis if you were to put it on the coordinate system. So the other one is a taller ellipse. It's elongated along the y-axis. But we're just going to focus on this first one, this pancake-shaped one. Okay, so major axis, minor axis. Now, the endpoints of the major axis, so right here, those are the vertices, okay? So each one is a vertex, but you have two of them, so there are vertices, okay? And then, let's see, I'm kind of running out of colors here. The endpoints of the minor axis, these are I'm doing in purple. Those are the co-vertices, okay? And they have coordinates. We'll talk about that in a minute. All right, and then we've got one more thing here. Let's see, I kind of need a different color. Well, I'll just put it in black. The foci are somewhere in between the center and the vertices, okay? And there's two of them. One is a focus and two are foci, okay? So I kind of lost my center, but my center is right there. So you'll notice that the vertices, the foci, the center are all along the major axis. So that's how that works. Now let's talk about some quantities here. So the distance between the center and the vertex is A. So this distance right here is A. And that makes the coordinates for this point A, comma, 0. And then over here, your vertex goes in the other direction, so it's going to be negative A, comma, 0. Okay? And then this distance, and you don't know anything about A yet, but you will. This distance here is B. Okay? And so the coordinates for this point up here are 0, comma, B, and then down here it's going to be 0, comma, negative B. Okay? Now, the equation for an ellipse looks like this. This one here, x squared over a squared plus y squared over b squared equals 1. That is the standard form for the equation of an ellipse centered at the origin. Okay? All right, so that's a good one to know. And for our purposes, we're going to say that A is greater than B. Now we have to remember that A is greater than B. Probably should put that someplace. Okay, but that's okay. And then we have one distance that we haven't talked about yet. Let's see. Well, it's the distance right here. I'm doing these all in the positive. That distance is C. So from the center to the foci, or the focus on one of them, is that distance is C. So the coordinates for that point Let's see if I can draw these in right here. The coordinates for that point are going to be c comma 0, and then over here the coordinates are going to be negative c comma 0. Okay, so hopefully that helps a little bit. I know it's a little messy. Now the relationship between a, b, and c is this: c squared is equal to a squared minus b squared. So you want to remember this part. Okay. The other stuff that I've written out there is all applying to an elongated ellipse. Okay. Now, I'm sorry, elongated along the x-axis, that kind of ellipse, a pancake ellipse, if you will. Okay. Now we're going to go and we're going to talk about the other ellipse. Its equation looks a little bit different. It's going to say x squared over b squared plus y squared over a squared equals 1. Now different textbooks handle this a little bit differently, but both the Math 10 textbook and the pre-calc book do it the same way. They're going to keep a larger than b, okay? Now that changes things then for our ellipse over here on the right. It's going to make the major axis this way, okay? And your end points here are going to be 0a and 0 negative a. I forgot to put the center in. The center is still, I'm just eyeballing these, but it's the center of the ellipse. Okay. I didn't really talk about how to make an ellipse, but you can read that in the book or look for a video on that. I'm just trying to go over some of the highlights and the mechanics of it here. Okay, so the minor axis is going to go this way, and the endpoints are going to be b comma 0 and negative b comma 0. So notice how even though they're similar, things are changing because of the orientation of the ellipse. And that is because they're saying A is greater than B, okay? All right, the foci then, let's see, we did that. What did I leave out? Oh, well, kind of lost my color system here. The foci are going to be along that major axis, so they're going to be somewhere in here and somewhere in here. Those would be the foci. And then the coordinates for those are going to be 0 comma c, and this one's going to be 0 comma negative c. Okay? So it changes a little bit. The box, though, stays the same, okay, for both ellipse. Whichever way is oriented. It's a pancake or an egg shape, I call it. A is greater than B, c squared is equal to a squared minus b squared. Okay. So that's information about the ellipse. Now we're going to show you an example. So here's an example. What's the standard form equation? So they want that x squared, so standard form equation, they're talking about x squared over, well, I don't know which way it's going to be yet because I haven't read all the information. X squared over something plus y squared over something. We'll figure out which way it goes in a minute, equals 1. Okay, and it's going to give us some information. They have to give us information if they want us to answer this type of question. It tells us the vertices are at positive 8, 0 and negative 8, 0. So I always like to draw things out. This is kind of a little big, but my graph paper. But my vertices then are here. So I know which way it goes. I don't know what B is yet. I'm going to figure that out. But I know it's this shape, okay? Because my vertices are along the x-axis, okay? I also know the foci. So the foci are at positive 5, 1, 2, 3, 4, 5, and negative 5. Now, you might say, well, why don't you, did I graph that right? No. Let me erase that. Put it where it's supposed to be. There we go. Why don't I graph it? Well, I don't know what B is yet, but I'm going to have to figure that out. So I'm going to use my formula that says c squared equals a squared minus b squared. And I know what c is, and I know what b is. This distance here, that is c. And so that's 5, or negative 5, and it doesn't matter because I'm going to square it. And then I know my a distance, there is 8. Okay, so 25 equals 64 minus b squared, or let's see, b squared equals 39, I think. Okay. Now, you might be interested in, well, what's the square root of 39? B would be equal to plus or minus the square root of 39. And that's not a perfect square, so I can get a decimal approximation for it. Let me do that real quick. Square root of 39. Yeah, it's about 6.2. So what that means, if I were to finish my graph here, I could go up 6, 1, 2, 3, 4, 5, 6.2, so a little bit above the 6, 1, 2, 3, 4, a little bit below the 6. And so I'm getting an ellipse. This probably isn't going to draw very good for me, but, ooh, well, it'd be nice if I would aimed for the right point. Okay, so trying to draw this ellipse. It looks something like that. So we just do our best when we're trying to graph these, but they don't even ask us to graph it. But if you were like, well, I want to complete the graph, I want to see what this ellipse looks like, that's what we're talking about there. Now, we don't actually need this information because what we're going to do, as soon as we found out that it was in pancake shaped, we knew that a squared was going to be under here and b squared is under here. And we have all that information. We know what a squared is, that's 64. And we know what b squared is, that comes from right there. And then that's the standard form equation for that particular ellipse.